Hello everyone, welcome back to Sulekha physics classes. Hope you all are doing good. Today in this video I will discuss about kinematics of a particle moving in a plane. Plane means two dimension. Two dimension is a combination of two one dimension. Suppose at any instant the particle is at point P and this one is x-axis, this one is y-axis, right? And when this particle moves from one position to another position, it changes, it covers distance both along x and y-axis. At this point, its coordinates are given by xy, right? So, in case of two dimension, we will discuss about position vector, velocity vector, displacement vector. In one dimension you know about position, displacement, velocity, but here we use position vector to represent the position of any particle at any time, right? Displacement vector when the particle moves from one position to another position. Velocity vector, we'll discuss all these things one by one, right? And after this, the best example for this motion in a plane means two dimension is motion of projectile. Another example is motion of satellite. But we will discuss in detail about projectile motion. Okay. So let us start with position vector. What is this position vector? Position vector tells about the position of an object at any point. Suppose the object is at point P. So what is the position vector? This is the position. Right? What is the position vector of this object? The distance from the origin to this point is position vector. It means OP. OP is the position vector and it is denoted by vector R. So this represents position vector of this point P, distance from the origin to this point. And how you write mathematically in rectangular components? Its coordinates is given by xy. Here I am going to use unit vector I along x-axis and unit vector j along y-axis. We already discussed these things in part 1 of this chapter, right? The vector analysis one shot. So suppose the position is at this point. So you draw one perpendicular. So this is the distance along x-axis and this one is along y-axis. So in rectangular coordinates, you write position vector r equal to x is distance along this x-axis. So we use I unit vector to represent direction. So xi plus yj. This is the position vector of this object, right? Now, after this displacement vector, this displacement vector comes when particle changes their position in the xy coordinates. Suppose the particle is at point P and after some time it changes their position to point Q along xy coordinates, right? So this PQ is nothing but displacement vector. Now, how you find this displacement vector? It is represented by change in position from one point to another point in two dimension, right now xy coordinates. So it is represented by delta r. Delta r represents displacement vector along from P to Q. It means along PQ. Its direction is along PQ, right? Now what is the value for this displacement vector in terms of rectangular coordinates? It means x and y. Okay, so the position vector of this P is suppose x1 y1 coordinate of this point P and position vector is r1. So let r1 is equal to x1 I plus y1 j. Again the coordinates of this Q is x2 y2. So the position vector, it means from O to Q is r2. R2 is given by x2 y plus y2 j. Now applying triangle law of vector addition. We already discussed these things in vector analysis right now. This is the position vector r1 for this point P and r2 is the position vector for point Q. So this applying triangle law and put displacement vector is from P to Q, right? So r1 plus delta r equal to r2. according to triangle law of vector addition. From here, delta r is equal to r2 minus r1. You put the value of this r1 r2 here. R2 is x2i plus y2j minus r1 is x1i plus y1j. So take I coordinates, I unit vector along one side. So this becomes x2 minus x1i plus y2 minus y1j. What is this x2 minus x1? Here at point P, along x-axis coordinates is x1 and at point Q x2. So x2 minus x1 is the change in distance along x-axis, how much change takes place, and this y2 minus y is change along the y-axis. So x2 minus x1, let it be delta x, it represents change along x-axis, I plus delta y j. So this is displacement vector. Displacement vector is change in position from one point to another point, and change when particle moves from one position to another, there is a change along x-axis and along y-axis both. So this delta r equal to change in along x-axis delta x I plus delta y j. So you must remember these things: position vector, distance from the origin to the point P, and it is given by r equal to xi plus yj, and this displacement vector delta r when particle changes their position from one to another. So delta r equal to delta xi plus delta yj. Okay, hope it's clear to all of you. Please take a screenshot. Right after this we'll discuss about velocity. Now average velocity, and after that instantaneous velocity. What is average velocity? Velocity is the ratio of displacement to the time taken. It comes when a particle moves from one position to another position in time interval delta t. So average velocity is given by change in this displacement by delta r in time delta t. So delta r by delta t is average velocity, and you know what is delta r? When the particle changes from one position to another, displacement vector delta r is given by delta xi plus delta yj by delta t, right? So delta x by delta t I plus delta y by delta tj. This delta x by delta t is what? Velocity along x-axis, and this delta y by delta t is what? Velocity along y-axis. So this average velocity is equal to average velocity along x-axis plus average velocity along y-axis. This is the expression for average velocity, right? And its direction is what? Its direction is same as direction of the displacement vector. From P to Q, displacement vector delta r. So average velocity is also from P to Q. So direction of average velocity is same as direction of displacement vector delta r, right? Hope it's clear to all of you. So this is about average velocity. Now what is instantaneous velocity? Here the time interval is very large. Average is used when the time interval is very large, change is very large. But when the change is very small, so when the time interval is very small, at that time we use instantaneous velocity. You know, in the vehicle, when you're driving any car or truck, anything, you know, a speedometer is there that gives the exact velocity at any time. That is nothing but that exact velocity is instantaneous velocity. It is velocity at a particular time. So how you get this instantaneous velocity? You just average velocity is this one. You just, when delta t time tends to 0, it becomes instantaneous velocity. So average velocity is given by limit delta t tends to 0 delta r by delta t. Delta r by delta t is average velocity, and when this time tends to 0, it becomes instantaneous velocity, right? So delta r by delta t, limit delta t tends to 0, this delta replaced by a small d when change is very small. So instantaneous velocity becomes dr by dt. Dr by dt means dx by dt along I-axis plus dy by dt along unit vector j. And what is this dx by dt? This dx by dt is velocity along x-axis, vxi plus vyj. This is the expression for instantaneous velocity. Velocity along x-axis plus velocity along y-axis. Now, if you want to find a direction of velocity instantaneous velocity at any point. So time interval is very small. So at this point, how you find direction? You just draw one tangent at this point. This tangent gives direction of instantaneous velocity at any point. So direction of instantaneous velocity is tangential to the part at the particular point and in the direction of motion, right? Now these are the expressions for average velocity and instantaneous velocity, right? What is the magnitude of this average velocity? Vxi plus vyj, this is the velocity vector. What is its magnitude? Magnitude is mod v equal to under root vx square plus vy square. And its direction is what? Direction is given by tan theta equal to vy by vx. So these are about average velocity and instantaneous velocity. After that, we'll discuss about average acceleration and instantaneous acceleration. Now, average acceleration. Average acceleration is the ratio of change of velocity of a body to the time taken. So, average acceleration you can write change in velocity by time taken. Now, change in velocity is what? Delta v by delta t, right? Now, you can write this velocity in rectangular components along x and y axis. So, this delta v becomes delta vxi plus delta vyj. Now, you separate these two components, delta Vx by delta Ti plus delta Vy by delta Tj. This delta Vx by delta T is what? Average acceleration along x-axis, Ax average I, plus this delta Vy by delta T is average acceleration along y-axis. So, Ay average J. So, average acceleration is A average equal to Axi plus Ayj. Average acceleration along x direction plus average acceleration along y direction. Now, what is the direction of this average acceleration? Suppose the position of the particle at point P, now it moves to point Q. Now, at this point, the velocity is along this tangent. You draw one tangent at point P, it gives velocity at this point V1. Now at point Q, what is the direction of velocity? You draw one tangent, it gives direction of velocity V2. Now what is direction of change in velocity? So using triangle law, first you draw V1, from one point you draw V1, and from the same point you draw V2. V2 is along this one, right? So V2 is along this one. So this is delta V, right? This is the change in velocity, delta V. V1 is along this direction, V2 is along this direction, and this represents change in velocity. Using triangle law of vector addition, V1 plus delta V equal to what? V1 plus delta V equal to V2. So delta V equal to V2 minus V1. These are Puji vectors, right? So this is the direction of change in velocity, and direction of average acceleration is same as that of average velocity, right? This is direction of average velocity also, and this is the direction of average acceleration also. Is it clear to all of you? So this is about average acceleration. Then instantaneous acceleration. It is nothing but average acceleration when time is very small, when delta t tends to 0. So you can write average acceleration equal to limit delta t tends to 0 delta v by delta t, and you can write limit delta t tends to 0 delta is replaced by small d, dv by dt. So you can write in rectangular components as limit delta t tends to 0, delta v is what? Delta vxi plus delta vyj by delta t. You separate these two components, limit delta t tends to 0 delta vx I by delta t plus limit delta t tends to 0 delta vy by delta t j. This becomes what? Limit delta t tends to 0 delta vx by delta t is nothing but dvx by dt. Instantaneous velocity, when time tends to 0, this rate of change of average velocity with times becomes rate of change of instantaneous velocity, right? Now I plus this delta v is replaced, delta is replaced by d when time tends to 0. So dvy by dt. So instantaneous acceleration becomes, this is what? dvx by dt is instantaneous acceleration along x-axis, axi plus ayj. Ay is dvy by dt, instantaneous acceleration along y-axis. So in this way, this is the formula for instantaneous acceleration. A instantaneous equal to axi plus ayj. And if you want to find its magnitude of a, then you can find under root ax square plus ay square. And again, what is direction of instantaneous acceleration? Actually, it is always perpendicular to average velocity, right? You note one point, direction of instantaneous acceleration is always perpendicular to average velocity. You note this point right now. Direction of this average acceleration is same as that of average velocity. This is direction of average velocity and this is direction of average acceleration also. But direction of instantaneous acceleration is always perpendicular to average velocity. So these are about acceleration. Please take a screenshot. After this, we will discuss about relative velocity in 2 dimensions. Now, next most important topic is relative velocity. What is relative velocity? Velocity of one object relative to another object. You know, everything in this universe is related to each other. Nothing is absolute. Absolute means independent. Everything is dependent on one another. So what is the velocity of one object with respect to another object? That is called relative velocity. For example, suppose here there are 3 persons, A, B and C. A is moving with velocity VA, B is moving with velocity VB, and suppose C is at rest, velocity of third person is at rest. Now when C observes A, its velocity becomes VA. When C observes B, its velocity is VB. But when B observes A, its velocity is different from VA. When A observes B, its velocity is different from VB. It means the velocity of same object is different for one observer and its value is different for another observer, right? So this is relative velocity. Relative velocity is velocity of an object relative to other object. So now when C observes A, so relative velocity of A with respect to C. Velocity of A when C is observing. You write in this way, VAC. VAC means velocity of A with respect to C. And you know C is at rest. So its velocity is 0. So he observes velocity of A is VA, simply VA. You can also write VA minus 0 or VA minus VC. Right now it becomes VA only because VC is 0. So it becomes VA only. Now second, relative velocity of B with respect to C. So again velocity of B with respect to C. So VC, he observes velocity of B as VB, right? Okay. Because this person is at rest, so he observes whatever is the velocity of B. Okay, and you can write in this way also VB minus 0, or you can write VB minus VC. Velocity of B with respect to C, it means VB minus VC, and it is equal to VB because C is at rest. Velocity of C is 0. Now in the same way, velocity of A with respect to B. Here I have written velocity of A with respect to C is VA. What is the velocity of A when B is observing? So relative velocity of A with respect to B. In the same way you can write this also. Velocity of A with respect to C is VA minus VC. So velocity of A with respect to B is VA minus VB. In the same way, relative velocity of B with respect to A is VBA, means B with respect to A, VB minus VA. It becomes more clear with the help of one example. Suppose its velocity of A is 10 meter per second, right? And velocity of B is also suppose 10 meter per second. Both are moving with the same velocity. So when C observes A, velocity of A becomes 10 meter per second only now. VA minus VC, VC is 0, so it becomes 10 meter per second. When C observes V, velocity of B becomes 10 meter per second because C is at rest. But when B observes A, both are moving with the same velocity. Try to understand it. Both are moving with the same velocity. So when B observes A, velocity of V A with respect to B, VA minus VB. VA minus VB is what? 10 minus 10, 0 meter per second. In the same way, when A observes B, velocity of B with respect to A, VB minus VA, again 10 minus 10, 0. It means what? Both are moving with the same velocity and parallel to each other, same direction. So both are at rest with respect to one another. A assumes that B is at rest and B assumes that A is at, right? Suppose A is moving with 20 meter per second and B is moving with 10 meter per second. In this case, C observes velocity of A as 20 meter per second and velocity of B as 10 meter per second. But when B observes A, velocity of A with respect to B becomes what in this case? VA minus VB. VA minus VB means 20 minus 10, that is 10 meter per second. Now in this case, when B observes A is moving with 20 meter per second, B is moving with 10 meter per second. So when B observes A, velocity of A becomes 10 meter per second, not 20, right? In the same way, when A observes B, velocity of B with respect to A, what is velocity of B? Velocity of B is 10, velocity of A is 20, it means minus 10 meter per second. What does it mean, minus 10 meter per second? A is moving with 20 meter per second and B is moving with 10 meter per second. So when A observes B, he assumes that B is moving with 10 meter per second in negative direction, because its speed is 20 meter and its speed is 10 meter. So A assumes that B moves with 10 meter per second in opposite direction, right? So one thing is clear, that here the two persons are moving in the same direction. When the two objects are moving in the same direction, relative velocity of one object with respect to another object is always difference between the velocity of the two objects. Now what is the physical meaning of this one? VAB. VAB is equal to VA minus VB. What does it mean? You can write this as also VA plus minus VB. Right? Velocity is a vector quantity. You put vector sign here, no problem, right? VA plus minus VB. It means velocity of A when B is observing. So velocity of A becomes velocity of A plus negative of velocity of B. So we assume that when one is observing, that person is assumed to be at rest and its velocity is negative to that of, and you add in that velocity, right? Here velocity of A with respect to B, it means B is assumed to be at rest and its velocity is negative of that one, it means minus VB. So velocity of A becomes velocity of A plus minus velocity of B. In the same way, velocity of B with respect to A, VB minus VA, right now? So you can write in this way, VB plus minus VA. Here velocity of B with respect to A means A is observing, so you assume A is at rest, and when A observes B, velocity of B becomes velocity of B plus negative of velocity of A. So one thing is clear, that who is observing, it must be clear that person is assumed to be at rest and its velocity is negative of its velocity and it is added to the whatever it is observing, right? Hope it's clear to all of you. So this is the case when the two objects are moving in the same direction. When the two objects are moving in opposite direction, so in opposite direction you always take along negative x direction, you take this velocity as negative velocity, right now? So here velocity of A with respect to B becomes VA minus of VB. So formula becomes VA plus VB when the two objects are moving in opposite direction. Here same direction, so VAB is VA minus VB. When the objects are moving in opposite direction, it becomes VA plus VB. You just add the two velocity, and velocity of B with respect to A, B is moving away from A. So velocity of B with respect to A, it becomes negative of VA plus VB. For A, velocity of B is, it appears that B is moving away from this A in negative direction. So negative of minus VA plus VB. So these are the two cases in one dimension. These are about relative velocity in one dimension, right? When the objects are moving in same direction, you just subtract the two velocity. When the objects are moving in opposite direction, you just add the two velocity, right? But what happens in this chapter, we have to discuss about relative velocity in a plane. Plane means two dimension. Suppose one object is moving along this direction and another object is moving along this direction. Angle between the these two velocity is theta. Now here the velocity are in two dimension. One is along this one object is moving along this direction, other object is moving along this direction. Now what is the relative velocity of one object with respect to another? How you find? Suppose you have to find relative velocity of B with respect to A. You know formula is what? VB minus VA. So relative velocity of B with respect to A. When A is observing B, so VB minus VA. Minus VA means velocity of A becomes what? In negative direction. A is assumed to be at rest and its velocity becomes negative. So VA becomes this direction, right? And VB is along this direction. And the resultant of these two is this one. This is velocity of B with respect to A. Here the angle is theta. So this angle becomes 180 minus theta. So you can find VBA equal to under root VA square plus VBA square plus 2 VA VB cos 180 minus theta. This is the formula for two vectors now, making angle theta. A and B are two vectors. So what is the magnitude of resultant? Under root A square plus BA square plus 2AB cos theta. Here there are two velocity vectors, VA and VB. Angle is 180 minus theta. So under root VA square plus VBA square plus 2 VA VB cos 180 minus theta. And cos 180 minus theta is what? Minus cos theta. So relative velocity of B with respect to A becomes under root VA square plus VBA square minus 2 VA VB cos theta. This is relative velocity in two dimension. And in your syllabus, in two dimension, you have to find relative velocity for rain man problem, right? Umbrella man problem, you can also say. Another example is for man boat problem, so river boat problem, right? River, you can say river boat problem, or you can say river swimmer problem, right? Anything you can say. So I will take one example for these two cases, rain man problem and river boat problem. First take a screenshot of this one. Now best example for relative velocity in a plane is rain man problem, or you can say umbrella man problem. You know, during raining time, in which direction open the umbrella, you don't know. You adjust the umbrella according to the speed of rain and speed of man. Okay, so it becomes clear with the help of this example. It is the case of relative velocity. Suppose rain is falling downwards, so relative velocity of rain is in downward direction towards negative y direction, right? And suppose man is at rest. So when you are at rest and rain is falling downward, you just open the umbrella upward, na, opposite to the direction of rain, right? How? So here relative velocity of rain with respect to man is what? Velocity of rain minus velocity of man, right now? And velocity of rain is what? In negative y direction. So you put negative sign here, right? Velocity of man is what? 0. So it becomes minus VR. Direction of this rain is in negative j direction. So minus VRJ minus 0. So it becomes minus VRJ. It means rain in falling in this downward direction, in negative y direction, and man opens umbrella in which direction? Positive y direction. You just open the umbrella in upward direction. This is the case when man is at rest. Now what happens when rain is falling downward and man is also moving positive x-axis, right, along forward direction, right? So rain is falling downward, man is moving in this direction. Now in which direction open the umbrella? So this is also the case of relative velocity in two dimensions. This is the diagram of rain man problem, and rain is falling downward, so VR is in negative y direction and man is moving in this direction. Now what is the relative velocity of rain with respect to man? Relative velocity of rain with respect to man is VR minus Vm. Minus Vm, you can write it as plus minus Vm. It means man is observing the velocity of rain. So you assume the man is at rest and you take negative of that velocity of man. So negative of velocity of man is in this direction, minus Vm. Now Vr is in this direction, Vm is in this direction. So resultant relative velocity of r with respect to man, by triangle law, parallelogram law, vector addition, resultant velocity is in this direction only, Vrm, right? Vrm is equal to rain is falling downward direction, it is negative y direction, you take minus Vrj in negative j direction, and it is minus Vmi, and resultant of these two you can find easily under root Vr square plus Vm square. Now this is direction of velocity of rain with respect to man. When man is observing, the velocity of rain is in this direction. Now in which direction man opens the umbrella? So let us suppose that this relative velocity of rain with respect to man makes angle theta with this rain, right? So here tan theta becomes what? This is suppose Vm and this one is Vr. So tan theta becomes Vm minus Vr. So man always opens the umbrella in direction opposite to the direction of rain. If rain is falling in this direction, man opens the umbrella in this direction. If this is theta, it means this, suppose this angle is theta. Here theta is the angle between this velocity of rain and this umbrella direction, right? So theta is angle between rain and umbrella. This is umbrella and this one is rain, right? And in which direction man opens the umbrella? Tan theta equal to Vm minus Vr. From here in this formula you can easily find theta, right? You know, greater the speed of the man or greater the speed of the rain, man bend the umbrella towards downwards because the speed of rain is very high. So if man opens the umbrella, if rain is falling in this direction, right now, man opens that umbrella in a vertically opposite direction, and if the speed of rain increases, it bends the umbrella in vertically downward direction. So this is the case of rain man problem and umbrella man problem. Now another example for relative velocity in a plane is river boat problem. I will solve one example for that one also. Take a screenshot. Now river boat problem, river swimmer problem. This one question also comes from this one. It's very important topic, right? This is also the case of relative velocity in 2 dimension. What happens? Suppose this is river is flowing in this direction. This is the velocity of river, right? And swimmer is at this side. Now a swimmer wants to cross this river from this one end to another end. But if the river is at rest, swimmer just cross the river along this one SB direction. But due to the velocity of river, swimmer wants to move from S to B by traveling this distance. But due to this velocity, swimmer moves in this direction, right? With the river, swimmer moves in this direction along SC. So swimmer has 2 velocity right now. One is along vertical direction, one is along horizontal direction. So they are different time. This is the minimum distance covered by the swimmer in minimum time. So in exams question comes that what is the minimum time to cross the river. So suppose width of the river is this one, BS is the width of the river. So minimum time is this one, minimum distance is BS. So minimum time to cover this distance is, you can find BS by speed of swimmer. And this, but the swimmer moves along this one SC direction due to the velocity of river. So this is the distance covered by the actual distance covered by the swimmer SC. So actual time you can find by SC by relative velocity of this river with respect swimmer with respect to river. This V is relative velocity of swimmer with respect to river. And swimmer has to cross this river from S to B, but swimmer reaches at C point. So this is the horizontal drift covered by the swimmer, BC. So in question also comes that you have to find this drift horizontal distance. So how you find? If you know the time, then you know velocity of river is along this direction, you can easily find drift horizontal drift, VR into T. So these are different cases. You have to find actual time, minimum time, then relative velocity of swimmer with respect to man, right? So you can easily find under root this Vs square plus Vm square. And what is the horizontal drift covered by the swimmer due to the velocity of river. So this is about river boat problem. So please take a screenshot of this one. Then after that, the most important topic, that is projectile motion. Now, the last and most important topic of this chapter is projectile motion. What is projectile motion? You know, when an object is thrown vertically upward direction, then under the action of gravity, after attaining maximum height, it returns back to the ground, right? And another, when an object is thrown along horizontal direction, then it moves in the same direction. So see the vertical motion and horizontal motion. But what happens when an object is thrown slightly different from this vertical motion, like this one? Okay, suppose object is thrown like this one. It makes some angle theta with the x-axis. Then what is the path taken by this object? This object covers distance both in x-axis and y-axis. So the path taken by this object is curved path, and this type of motion is called projectile motion, and the object which is thrown is called projectile, and this angle with which the object makes some angle with the x-axis is called projectile angle. So projectile is an object that is in flight after being thrown or projected. Now, in projectile motion, there are different terms related to projectile motion. First is, an object attains a maximum height. After that, it returns back to the ground. So this maximum height, this is the maximum height attained by the object. So you have to calculate the value of this one. Then the total time during the flight from this to this is capital T. You have to calculate capital T also. Then the horizontal distance covered by the object, that is called range. It is, so you have to calculate this range also. So we have to calculate maximum height, time of flight, range, everything. But first we have to prove that the path taken by this object, this is curve, na? This is called parabolic path, and the path is also called trajectory. So first thing which is very, very important to prove that the path of a projectile is parabolic. You know, parabolic equation is y equal to 4 ax square, or x equal to 4 a y square, right? So you have to prove that the path taken by the projectile is parabolic. It means parabolic form. You have to find the equation. So for that, let us suppose that an object is thrown with some angle theta with the x-axis with an initial velocity u. Now this initial velocity u has two components, one along x-axis ux and another along y-axis uy. Okay, so this object has two velocity, one is along x-axis, that is ux, and ux is u cos theta, and along y-axis uy, that is u sin theta. Now after time t, the object is at this point. Suppose this point is C. Okay, this is A, this one is B. Now after total time t, the object reaches at this point C. Now you know that along horizontal direction, if we neglect air resistance and friction, then along horizontal direction there is no acceleration. So acceleration along horizontal direction is 0, and acceleration 0 means velocity along horizontal direction is always constant. So along horizontal direction there is no acceleration and ux is always constant, right? But along vertical direction, this uy under the action of gravity, object again come back to the original position. So there is some acceleration due to gravity along vertical direction. So along vertical direction there is acceleration due to gravity g, and its velocity is changing. First, when an object is thrown, its velocity decreases and becomes 0 at the maximum height. Then again during downward motion its velocity increases, right? So at the maximum height its velocity becomes what? Final velocity along vertical direction becomes 0, but along horizontal direction there is no acceleration, so velocity is always constant, right? So these things you must remember, that along horizontal direction there is no acceleration, velocity is always constant. Along vertical motion there is some acceleration due to gravity. During upward motion, acceleration due to gravity is minus g, and during downward motion acceleration due to gravity is plus g, right? Now you have to prove that path of projectile is parabolic. It means you have to find a relation between x and y distance, right? So first I consider along horizontal motion, distance is what? There is no acceleration, just distance is speed into time. Speed along horizontal motion is ux into time. T is the total time from A to C, time of flight. So ux is what? U cos theta into t. From this equation you find t equal to x by u cos theta, equation number 1. Now along vertical motion there is some acceleration due to gravity, so you have to apply equation of motion under gravity. So you know s equal to ut plus half at square. So along vertical direction you take distance y equal to velocity, initial velocity along y direction is uy into t plus half acceleration along y direction is ay into t square, right? Now ui is what? Uy is u sine theta, right now, into t minus half ay body is thrown vertically upward against the gravity, so minus g you take. So ay is minus g, so equations become u sine theta into t minus half gt square, and you put the value of t from equation 1, it becomes this u cancel, x sine theta by cos theta is tan theta minus half g by u square cos square theta into x square. So this equation is of the form y equal to px minus qx square. This is p, this is a constant, and these terms are q. So I can write y equal to px minus qx square, right? P and q are constant. So this equation is linear in y and quadratic in x. It means y equal to px minus qx square. This equation is linear in y and quadratic in x. This shows that the trajectory of a projectile, or you can say path of a projectile, is parabolic path. So to prove trajectory of a projectile is parabolic, you have to prove parabolic equation in this form, y equal to px minus qx square. Okay, so this one is very, very important to prove that path of the projectile is parabolic. For this you have to prove like this one. Hope you understood. Take a screenshot, then we will find different values related to projectile. Now after proving trajectory of a projectile, there are different terms related to projectile motion. First one is time of flight. Time of flight is what? Total time taken by a projectile to reach the ground. Suppose a projectile is projected from this point A, and after covering this curved part it reaches on the ground at point C. So what is the total time taken by this projectile to reach on the ground? This is time of flight. So total time, how you find? You first consider the vertical motion, right? So total time starting from A, and after t time it reaches to point C. So there is no vertical displacement now. So you can take y equal to 0. Net vertical displacement up to C is what? 0. Then equation of motion is what? Y equal to uy t plus half at square. At means ay, acceleration along y. You are writing equation along vertical motion, right? So here y is what? From A to C there is no displacement along y vertical direction, so y is 0, uy is u sine theta into t, ay is what? Ay is minus g, right now upward motion, so minus half gt square. From here you find t equal to 2u sine theta by g. This is the expression for total time taken by the projectile to reach the ground. It means from A to C, time taken by the projectile is capital T, time of flight. It's given by 2u sine theta by dg, right? Now You must remember this formula. It's very helpful when we are solving numericals and MCQs also, right? Second one is maximum height of a projectile. This is the maximum height of a projectile. When you throw projectile with some angle theta, after attaining maximum height, it returns back to the ground. So what is the maximum height attained by this projectile? This is maximum height of a projectile denoted by capital H. It is maximum vertical distance attained by a projectile, right? Maximum vertical distance attained by the projectile is called maximum height of a projectile. Again, you are considering vertical motion. So during vertical motion, acceleration along y direction is minus g, velocity along y direction is u sin theta, and at maximum height, final velocity along y direction becomes what? 0, right? So Vy equal to 0. Now using second equation of motion, v square minus u square equal to 2as. V square means Vy square minus initial velocity uy square equal to 2a. S is the vertical distance. So here I have taken capital H. Now Vy is what? 0. This becomes 0. Uy is u sin theta whole square equal to a is what? A is along y. So ay is what? Minus g. So here you put ay minus g minus 2gh, minus minus cancel, h becomes u square sin square theta by 2g. This is the expression for maximum height attained by a projectile. H equal to u square sin square theta by 2g. No confusion here. 2u sin theta by g. Time of flight. Here h is u square sin square theta by 2g. You remember this formula. It's very helpful for MCQs and many questions you can solve with the help of this formula, right? Now after this, third one is horizontal range. Horizontal range is this one from A to C. During its total flight, total horizontal distance traveled by a projectile during the total flight, right? Time of flight is t. So in total time t, how much this projectile covers horizontal distance? This is horizontal range. Total horizontal distance traveled by the projectile during time of flight. So here I am considering horizontal motion, right? So along horizontal motion, initial velocity ux is always constant, that is u cos theta. There is no acceleration along x direction, horizontal, ax is 0, and this x distance I have taken here capital R, horizontal range. Equation is x equal to uxt plus half axt square. X you write R, ux is u cos theta into t. T is what? T is 2u sin theta by g, you put here, plus acceleration is 0. So you put here 0. From here, you calculate R equal to u square, this u multiply, then 2 sin theta cos theta. 2 sin theta cos theta is what? 2 sin 2 theta, right now? Sin 2 theta is 2 sin theta cos theta. So you write sin 2 theta by g. So this is the formula for horizontal range, right? U square sin 2 theta by g. All formulas are very important. Time of flight, 2u sin theta by g. This is maximum height of a projectile, u square sin square theta by 2g. This one is the horizontal range, u square sin 2 theta by g. Now for maximum range up to some distance, na projectile return back to the ground after covering maximum distance. So at what angle you throw the projectile to attain this maximum horizontal distance? So for maximum R, okay, where I write? Okay, here. For maximum range, right now, for maximum range, this sin 2 theta becomes what? Maximum value of this one is 1. So here you can write sin 2 theta equal to 1 is what? Sin 90 degree. It means 2 theta equal to 90 degree and theta equal to 45 degree. This is the angle at which horizontal range is maximum. When you throw any projectile with this angle 45 degree, then the projectile attains maximum horizontal distance it covers, right? So these are the different expressions for time of flight. Remember this one, maximum height, this one, and this range. And for maximum range, theta is always 45 degree. You must remember this point also. It's very, very important. So hope you understood everything about projectile motion. Please take a screenshot. Then I will solve one example. Now I am going to solve one numerical based on projectile motion. I have taken this numerical from NCERT book, I think 4.13 or 4.14. The question is, the ceiling of a long hall is 25 meter high. There is a long hall and the ceiling of this long hall is 25 meter high, right? What is the maximum horizontal distance that a ball is thrown? A ball is thrown like this one, okay? That a ball is thrown with a speed of ball is what? It's given 40 meter per second, can go without hitting the ceiling of the hall. You have to find this maximum horizontal distance that a ball can go without hitting the ceiling of the hall. So you have to find this maximum horizontal distance, that is range. And what is given here? Here given this height, maximum horizontal, this vertical height, right now. H is given, H equal to 25 meter, U is given 40 meter per second. Now with the formula, now using this formula, H equal to U square sin square theta by 2g. This is the formula for maximum height attained by the projectile body, right? So this H is what? 25, U is 40, sin square theta by 2g. J you take 10.8 and 10 also, right? From here you can easily find sin square theta and then sin theta. Sin square theta is 0.306, then sin theta is under root 0.306, right? You can find from here theta also, but if you find cos theta with the help of sin theta, then it becomes easy to find the range, right? So cos theta is what? Under root 1 minus sin square theta. So under root 1 minus 0.306, it becomes under root 0.694. So here I have got the value of sin theta and cos theta. No need to find cos theta if you directly find the value of theta from this equation. But I have find this cos theta so that the calculation becomes easy, right? So after finding sin theta and cos theta, now I have to find maximum horizontal distance. Formula for this one is what? Range. U square sin 2 theta by g, right now. So sin 2 theta is what? 2 sin theta cos theta. So just you put the value of sin theta and cos theta here. U 40 square divided by g 9.8, you get the maximum horizontal distance that a ball can go without hitting the ceiling of the hall, right? So this R is 150.7 meter. It means this distance is what? 150.7 meter. This is the maximum horizontal distance that a ball can throw without hitting the ceiling of the hall, right? Maximum horizontal distance attained by the ball is 150.7 meter. So in this way you solve many questions based on projectile motion, right? So please take a screenshot of this one. Now with this I am going to end the class. Hope you like this one short series of motion in a plane, and in this one I have covered which topic? Projectile motion and relative velocity, right? So okay students, keep revising and stay tuned with this channel. Thank you.